Oh, here.
Good afternoon, everyone. My name is Raja Chakravarty. I'm a professor and department chair of astronomy and astrophysics at the University of California, Santa Cruz. Welcome to the Bay Area Drama Company's presentation of the square root of a sonnet. In preparation for the show, I have a few housekeeping announcements. This is an excellent time for each of you to please turn off your phone and put it away for the duration of the show. The run time for the show is 100 minutes, and there will be no intermission. Emergency exits are located to the back of the theater, the left and right. Please wear a mask at all times while you're in the theater building. That's what I have by way of housekeeping announcements. Now, I was a graduate student at Princeton University in the late 1980s when the great Subramanian Chandrasekhar visited Princeton's Institute for Advanced Study, the very place where Albert Einstein had been a professor decades earlier. Chandrasekhar's Princeton visit took place a few years after he had been awarded the 1983 Nobel Prize in Physics, a prize he shared with Willy Fowler. My fellow graduate students, astrophysics graduate students, and I had the wonderful privilege of spending an afternoon with Chandrasekhar, and we discussed a wide range of topics. The following evening, my friends and I went across to the Institute for Advanced Study to listen to Chandrasekhar's guest lecture. And the title of his lecture was, Newton or Einstein? Who was greater? Newton or Einstein? Indeed, this is exactly what was at stake when Sir Arthur Eddington, long before he became Chandrasekhar's mentor at Cambridge, led an expedition to the island of Principe during the total solar eclipse of 29th May 1919. Eddington went there to make precise measurements of the relative apparent positions of stars during the eclipse. The play you're about to experience is about two greats of 20th century physics, Subramanian Chandrasekhar and Sir Arthur Eddington. The play is also about their equally brilliant, and in some cases even more famous, colleagues. The story is as much about the scientific process, by that I mean theories, experimental evidence, discoveries, as it is about the people involved in that process. Personalities, human frailty, relationships, conflict. You will see that the total solar eclipse of 1919 features prominently in the play. So I want to explain the significance of that eclipse here. A few years before that 1919 eclipse, Albert Einstein had made the remarkable prediction that starlight can be bent by gravity. It was quickly realized that a total solar eclipse presents an ideal opportunity to make precise measurements of the apparent positions of faint stars, while the intense glare of the sun is temporarily blocked by the moon. Eddington's measurements of stellar positions during the 1919 solar eclipse proved that Einstein's theory was correct. According to Einstein's general theory of relativity, a more modern and sophisticated theory of gravity than Newton's, any object with mass, the sun in this example, but any object with mass, warps space and time in its vicinity. This warped space-time then bends the trajectory of absolutely anything and everything, including light. In the play, the main point of contention between Chandrasekhar and Eddington is the implication of Einstein's relativity on the end state of massive stars. By massive stars, I mean stars that are significantly more massive than our sun. It was known at the time that the sun and other stars of comparable mass end their lives as white dwarfs. Chandrasekhar's calculation indicated that if a star's mass exceeds 1.44 times the mass of our sun, then it cannot end its life as a white dwarf and must instead implode, not explode, but implode under its own gravity. This critical mass, 1.44 solar masses, has come to be known as the Chandrasekhar limit. Today, we know that stellar remnants whose mass exceeds 1.44 solar masses do indeed implode at the end of their lives and become neutron stars or black holes, depending on their mass. Finally, there's a second kind of privilege that I enjoy. Turns out that Chandrasekhar is my great-grand doctoral advisor. What was I about to say? Great-grand doctoral advisor, and that makes Eddington my great-great-grand doctoral advisor. What I mean is this. One of my two doctoral advisors was Jim Gunn. Jim Gunn's doctoral advisor was Guido Munk. Guido Munk's doctoral advisor was Chandrasekhar. And one of Chandrasekhar's two doctoral advisors was Eddington. Now, last evening, the audience included two of my doctoral students, Amanda and Doug. Amanda is a freshly minted PhD from earlier this week. And in the audience last evening was Ivana, one of my doctoral grant students. What I mean is this. I am Ivana's doctoral advisor's doctoral advisor. So if you're following all this, it means that Eddington is Ivana's great-great-great-great-grand doctoral advisor. 4 grades. Now, the student-advisor relationship is a relationship of trust. Often, your beliefs, convictions, your stance on a scientific debate is determined by who your advisor or mentor was, or even who your advisor's advisor was. There are websites out there that track the genealogy of student-advisor relationships. Eddington was Chandrasekhar's mentor. Their complicated relationship is at the heart of this play. At the end of this play, there will be a very short break, followed by a talk back during which Ranjita Chakravarty, the director of this play, Basha Pradhan, the artistic director of Bay Area Drama Company, and I will field questions from you, the members of the audience, about the science that's discussed in the play, or about the history of the scientists portrayed in the play, or really anything about the play that you care to ask about. Folks, I will see you again during the talk back after the play. Now, please sit back, relax, and enjoy the square root of a sonnet.
Busy with your stars as usual?
Not stars, black holes. Beautiful, aren't they?
Well, I suppose it depends on one's tastes. For you, black holes have always been the most beautiful things in the universe. Your first child, your only child.
The most perfect objects in all of creation. The most complex, and yet the simplest. Born from the union of quantum mechanics, special relativity, and general relativity. Three of the greatest triumphs in the history of human thought. Look at them. Thousands of them, floating in space, devouring stars 100 times larger than our sun, and yet occupying space smaller than a trillion-year period. Bending the fabric of space-time into infinitely deep wells from which nothing can escape, not even light. But time slows down to a trickle, and the seconds creep forward at the pace of a summer afternoon in Madras.
Especially after a heavy meal of sambar and rice.
Digesting entire stars in their bellies without popping out the smallest bit of information.
Strange things, these black holes. Mysterious. Just like you.
Mysterious? Me? You must be joking.
I am not. Chandra, we were married for 59 years. Yet there is so little of you that I really know.
But we never stop talking, Lalita. Now that you're here, we have all the time.
Well, I'm glad you finally noticed me, even though I'm not as beautiful as one of your black holes.
I've been dead for over 20 years now, Lalita.
And died for 20 minutes, I think.
You're dead? But when? How?
Old age, of course. Just before I would have turned 103. Thank God it was quick and painless in the end. The doctor was still writing on the death certificate when I suddenly found myself in this place. How or why? I don't know. But here I am, hale and hearty, and feeling 50 years younger. Speaking of which, where is here?
No idea. Came here by accident, just like you. Lost track of how long I've been here. Not that I'm complaining. What with the ringside view to the splendors of the universe?
Ah, I think I know where we are.
Where?
Heaven. Swarga.
Ah,
Our own little private versions of heaven. I have my home to myself again, and you have your stars. And we have time in a place where there is no time. Or perhaps I'm intruding.
ah, Lalita. You are the only person I have ever cared. You know that. And look, here's the proof.
That's there, Chandra, because this is my side of the house. I notice your side only has a photograph of Ramanujan.
I'm not going to argue with you. Anyway, welcome to heaven.
Swarga.
Swarga, I think you'll enjoy yourself here. There are no worries here. No dreams, no failures, no sarat. What's in that box?
Oh, nothing. Just some things. A box full of memories, you can say. What else can the dead bring with them?
I doubt that you'll need anything here, Lalita. We're no longer creatures of flesh and blood, but spirits, things of fire and air.
Just like your beloved stars, you are always more concerned about things of fire and air, symbols and equations. But I needed something more substantial, more earthly, so to speak. My memories, they're as real for me as your equations are for you.
Till eternity with one's memories. Sounds like a nightmare to me.
Try spending it without memories and see how that feels. You died and I spent the last 18 years just thinking about the old days. Remember this?
Atomic Structure and Spectral Lines by Arnold Sommerfeld.
Your first gift to me. Oh, look, the inscription's still there. To dear Miss Lalitambika Duraiswamy, yours respectfully, S. Chandrasekhar, Madras, 1928.
Of course, I remember. I gave this book to you when we went for our walk on Marina Beach.
Our first walk together. Chandra, did it ever occur to you that gifting a book on atomic structure and spectral lines might not have been the best way to impress a girl?
But it's a beautifully written book. I thought you'd enjoy it. You used to like physics.
You know what they call people like you these days?
What?
I believe the expression is nerd. N-E-R-D.
Just as well that I'm no longer alive these days.
Oh, how time flies. Sometimes I wish we could stop it like one of your black holes. It seems only yesterday that you gave me this very nerdish gift. We were only 18 then, both of us.
You were 4 days older than me, although a year junior at college.
I'm surprised it was only a year. What with your dizzying academic success, winning every scholarship medal in sight, publishing papers.
On the Fermi Dirac statistics, only then discovered.
The rest of us were still struggling with basic calculus. And there you were, discussing quantum mechanics.
With Heisenberg, on his first visit to Madras.
The boy wonder of Indian science, the true heir to your Nobel Prize winning uncle. You had barely graduated to wearing long pants.
I think it all went to my head. I remember kneeling down on the seashore, praying to God that I could become like Newton and Ramanujan. Such delusions of grandeur.
Oh, is that what you're praying for? How disappointing. I thought you were praying for me. Oh, come on, Chandra. Don't think I didn't notice those glances you used to sneak at me in college? So shy. Those attempts to strike up a conversation? So clumsy.
Mea culpa, Miss Lalitambika. I fell in love the moment I set my eyes on you. I have no hesitation admitting it.
Love? Really? This? And what happened to all that love when you went away to Cambridge? You hardly ever wrote to me. A short letter once or twice a year, perhaps, but apart from that, it was one long silence for 6 years, until we finally decided to get married.
I'm sorry, I was just very busy in those days with my work.
So busy that you couldn't even tell me what happened between you and the great Mr. Eddington? Why you suddenly decided to leave Cambridge? Why you vanished to some obscure little town in America in the middle of nowhere?
I don't think I told anyone about all that. What was the point? No one could have done anything about it.
Except your father, it seems. The two of you wrote plenty to each other when you were too busy to write to me. And it would appear that you've even found a solution to your Eddington problem. My dear Chandrasekhar, do not postpone your marriage for too long.
Let all intellectual ambition go hang. Come over in the Christmas week of 1935 and get married. If you are here in Madras for about 4 months, you'll meet a few girls, then choose. The Indian way of love is far superior to the European one. The wife you need is the one who will be a comrade to you, but also see that your home interest is attended to. Yours, Babuji. You know what Indian fathers are like. They think marriage is the solution to all problems.
And what did you think, Chandra? No, seriously, why did you suddenly decide to marry me after 6 long years of silence? Was it because you needed someone to attend to your home interest? Or was it because you had no friends in Cambridge? Or was it because you'd been rejected by Mr. Eddington?
Stop it, Lalita. You're teasing me. You are all that I've ever wanted. And look, I even have documentary evidence.
Of that interview.
Yes, taken soon after my Nobel Prize award. So the journalist asked me, Professor Chandrasekhar, how will you sum up your life, sir? Well, I left India and went to England in 1930. In 1936, I went back to India and married a girl who had been waiting for me for 6 long years. We went to Chicago and lived happily thereafter.
All lies, but nice lies. I wish you'd said those things to me when you were young, instead of trying to impress me with your spectral lines. Now go back to your stars and let me attend to my work, my home interests. Chandra, stop throwing things around the house. What's this? Maximum massive ideal white dwarfs.
I wish you hadn't brought that here.
Hadn't brought it here. Your seminal paper on the fate of stars, your finest achievement.
I was only 19.
The discovery of the Chandrasekhar limit.
Yes. Chandrasekhar limit. I believe I know something about it. 1.44 times the mass of the sun, our sun, the mass above which a dying star collapses into a neutron star, and a more massive star collapses into a black hole. They were kind enough to name it after me.
Even though it took them 30 years to do it.
Even though they called it the Landau limit for decades. Oh yes, I suppose I should be happy that I discovered the Chandrasekhar limit. Or perhaps the limit of Chandrasekhar.
Chandra, why must you be so dismissive of your achievements? You did by 19 what the rest of us could only dream of doing in an entire lifetime.
It must be a single point question in some entrance examination or the other in India. Question. Name the 3 most important contributions by Indian physicists.
Answer. The Raman effect, the Bose-Einstein statistics, and the Chandrasekhar limit.
Countless young men and women appearing in the civil services examination must be thanking me for raising their scores by 1/3 of 1 point.
But it's what made you, Chandra. It's why the world remembers you today. You should have heard them talking about you when you died. S. Chandrasekhar, the most distinguished astrophysicist of our age, Nobel laureate, brilliant mathematician.
Yes, it made me. But it also destroyed me.
Destroyed you.
You know what happened after I published that paper?
Sir Arthur Eddington? Chandra, you still think about him?
There are some memories that don't need preserving in a box.
Why did he do it?
I don't know.
You know, you never told me much about him. What was he like?
Eddington? He was an enigma. Like each one of us, I suppose. Square roots of sonnets. That's what he used to call human beings. Impossible conundrums, unsolvable equations. What can I tell you about Eddington? He was the father of modern astrophysics, celebrated mathematician, lover of Shakespeare and crossword puzzles, an interpreter of the universe.
Just listen to you talking about him after what he did to you. Even in your Nobel acceptance speech, it was Eddington, Eddington, Eddington all the time.
Only 11 times.
I could never understand why.
He was my hero, Lalita, my guru. Without his fundamental insights into the working of stars, I could never have come up with the Chandrasekhar limit.
Guru indeed, Sir Drona, he cut off your thumb without even asking for it, and you went on paying Guru Dakshina to him for the rest of your life.
He was a great scientist. He laid down the path for the rest of us to follow. He came up with the first working model of the stars, which was really the birth of modern astrophysics. And he was the first person to truly understand Einstein's general theory of relativity, and prove it as well, in spite of being disowned by his English colleagues for supporting a German scientist.
May 1919. World War I had just ended 6 months ago. Germany had been destroyed by the Allied powers, but one German stood tall amidst the ruins, Albert Einstein, with a theory of gravitation that had turned the Newtonian universe on its head, a strange and beautiful theory that had the English scientists breaking into a cold sweat, because Sir Isaac Newton, their great national hero, was about to be proved wrong. The obscure calculations made by a former clerk in the Swiss Patents Office were about to end over 200 years of dominance of British science. Only one thing remained for German science to achieve eternal glory: proof. Experimental proof. And the person to provide it was Sir Arthur Stanley Eddington, Professor of Astronomy at Cambridge, who used all his wisdom and cunning to persuade the Royal Astronomical Society in London to sanction that famous expedition to Africa, which was to become the final battleground between Newton and Einstein.
Africa? Arthur Stanley Eddington, have you gone quite mad, Arthur?
On the contrary, my dear sister, I have never been saner.
And just where is it you are sailing off to?
Well, tomorrow I set sail for the Dark Continent, the tropical island of Principe, off the west coast of Africa. Oh, Winnie dear, do remember to pack my gumboots and a pair of woolen socks. The weather, unfortunately, threatens to be soggy.
And why must you go there, Arthur?
Oh, a tiny corner of the universe is behaving badly.
Ah,
And I must voyage to Africa to set it right.
it is so difficult to live with a man who speaks in riddles all the time. Is this about that German again?
Well done, my dear Watson. It is indeed about Mr. Einstein. And I am soon going to prove that his theory of gravitation is indeed the right one.
Herr Einstein's theories can't be very good, can they, if they work only in Africa and not in England? Look at dear Sir Newton's. They work perfectly well just about everywhere, it seems. Why on earth should we send good English scientists scurrying about to the ends of the world to prove bad German theories?
Because these bad German theories, as you call them, could alter our understanding of the universe itself forever, in deep and fundamental ways.
Does it bother you at all, dear Arthur, that we were at war with Germany only until yesterday? They have the blood of so many of our countrymen on their hands. Of our own friends. Must you really go this far to help prove a German right, Arthur? Don't your colleagues at the Royal Astronomical Society have anything to say about it?
Colleagues, the blighters, they nearly ostracized me. But I couldn't give a bugger about it.
Arthur?
Sorry, my dear. But the squabbles of politicians and generals, they come and go. They can't be allowed to get in the way of the truth. Listen to me, Winifred. For over 200 years now, Newton's laws have explained everything that we know about motion, from the fall of an apple, to the rise of the tides, to the orbits of the mighty planets, to the flight of the humble bumblebee.
Hurrah for Mr. Newton!
Everything that is, except for the tiny planet of Mercury. A most ill-mannered little planet, just like someone we know, who simply decided that it simply will not do what the good Mr. Newton wants it to do.
And what does it matter? It's a tiny little planet, as you say.
I'm referring, of course, to the long-standing mystery of the anomalous rate of the precession of the perihelion of Mercury's orbit and its inexplicable deviation from the elliptical path ordained by Sir Isaac by 43 arcseconds in a century.
Of course! That explains it all! Silly me! I think I'll just go and pack your gumboots.
Oh, blow my gumboots. Here, let me show you. Now, if you were the sun...
No, Arthur Stanley Eddington. You are the sun. The brilliant sun. I am only the daughter. Oh, yes. Destined to circle around you in a never-changing orbit of packing gumboots and boiling eggs for your breakfast. Now you go on with your little games. I have lots of Earth stuff to do.
No, wait. This will only take a minute. Now, imagine you are the sun, and I am the planet Mercury, gingerly making its way about your brilliant self. And just as the great Newton would require me to do, I, Mercury, am tracing out an ellipse with the sun at its focus. All is well with the universe so far. But watch what happens with each passing year. The orbit is shifted from the previous orbit by the fraction of a whisker.
My head is spinning. I don't know if it is from your ellipses or Einstein's whiskers.
Just one whisker every year. But 100 Mercury years later, and the whiskers have added up, and the shift is palpable by the 43rd part of 1 degree to be precise.
The angle at the tip of a grim German moustache.
Much less, I should say. But it is on such fine differences between observation and theory that lie our first misty glimpses of the truth. A truth that is much deeper than anyone has conceived of so far.
A truth that doesn't matter to anyone except grown men who want to avoid doing any real work by whiling away their time staring at the stars.
Well, that is a pickle of your own making, Winnie dear. You are sinking into a gutter of mundanities.
Well, you leave me to my sinking, and I leave you to your thinking. I shall await for the day when your thoughts on the universe will prove to be the slightest use to the rest of us.
And such a day will come. You mark my words. History is on my side. You know, when he was still Chancellor of the Exchequer, Prime Minister Gladstone once asked Sir Michael Faraday, Mr. Faraday, of what practical use is your electromagnetism? To which Faraday had replied, why, sir, I have every confidence that one day the government shall be able to tax it.
Very clever, Arthur. Then I shall patiently await for the day when we can tax planet Mercury. Perhaps Mercury will finally mend its ways then. Speaking of which, why does it behave so oddly?
Oh, because it is so much closer to the sun than any other planet.
Ah, the heat gets to it.
No. It's because the space around Mercury is distorted by the enormous mass of the sun. Just like a wrinkled cloth.
Space is like a wrinkled cloth. Silly me, I thought it was just empty.
But you see, Einstein has radically altered our understanding of space and how objects move about in that space. Newton had explained motion in terms of a mysterious and invisible force called gravity, which causes any two objects to be attracted to each other, just like a pair of magnets. An apple falls towards the earth, like this, because the earth pulls it towards itself. But on the other hand, Mercury revolves around the sun, like this, because the same invisible force is used for an orbiting, not for folding.
Of course, as every schoolboy knows.
But on the other hand, what every snotty-nosed schoolboy does not know is that Einstein's conception of gravity is based entirely upon geometry and no other mystical forces. Einstein's equations show that matter bends space, and objects move along that space along the contours that are created.
Right. I think your socks need a wash, so if you and Einstein don't mind...
Oh, stuff my socks! I'm about to make history and you don't even want to know about it. Now, how can I explain this to you? I have it.
Oh.
Here, Winnie. Take a hold of the other two corners of this cloth, will you?
Oh, off he goes again.
Oh, just do as I say, will you? For heaven's sake, I'm constructing the solar system here.
Oh, of course, dear God.
Now, Winnie, stretch out the cloth. There. Now, you see, this is space.
This cloth is space.
When there is no matter, no mass to bend and twist, it is a smooth, flat surface along which all objects must travel in straight lines, like this. Ah. Now, Winnie, I need to wait.
Wait.
Here's an apple.
Hungry already, dear God. We've only just started on the solar system. There's plenty more to go.
Now, when I place this apple, what happens to the cloth?
Why it sags.
It bends and curves. Space bends and curves when a weight is placed. And when a second, not so massive object makes its entry into this little drama, it has no choice but to...
But to move around the contours of the cloth.
Yes, the apple is the sun, and the ball is Mercury. Mercury moves not because of the invisible force of gravity, but because of the inexorable laws of geometry.
Impressive.
Gravity becomes merely a consequence of geometry. It is impressive.
Yes. Except...
Oh, now what?
Well, I do want to point out, if I may, that Mercury still seems to be moving around the sun, exactly as Newton said it would.
Yes, and so?
So what was all that fuss about the precession of the periwinkle then?
The precession of the perihelion.
Whatever.
Like I told you, it's because Mercury is so perilously close to a body as massive as the sun. An enormous mass, such as the sun, creates wrinkles in the fabric of space-time, and it causes nearby objects to wobble.
As little children in the presence of a big bully.
Close enough. And Newton's laws simply cannot explain all of the wobbling, whereas Einstein's can.
So off you are to Africa to measure the wobbling of Mercury.
Precession. And no, that's been done already. And Einstein's predictions match perfectly with the observations. But it isn't enough. I'm off to Africa to measure and prove the second of his fascinating predictions. And that will be the definitive proof that he is right.
That a ping-pong ball traces a circular pattern around an apple that is placed on a scarf. Thank you, I knew that already.
Except this time, imagine that the ping-pong ball is not a planet. Imagine that it is a ray of light from a distant star, let us say. Now, what would happen if that ray were to whiz past the sun?
It would bend.
Ah.
The ping-pong ball, your ray of light, would curve past the apple, the sun. But that means...
That means...
That means...
That means that light does not travel in straight lines. It follows the curvature of space just like any material object. Matter shapes space, and space shapes the trajectory of both matter and light. Light does not travel through the cosmos along a straight and narrow path. It does not move with the determination of an Englishman making a beeline for the nearest pub, but rather like an English woman whose fancy may be caught by the latest display of silk gowns and hairs.
But why? Matter has mass, it has weight, whereas light is, well, just light.
But light is energy, and energy is mass. E equals mc squared, which was also proved by Mr. Einstein 14 years ago, his special theory of relativity. Hence, light too is also bent in space by mass. Oh, don't look so shocked, Winnie, it's true.
I was just thinking, what if...
Fancy that. But, let me stop you.
I was wondering, what would happen to space if the object were heavy? Really heavy? Wouldn't it create a deeper and deeper well then?
Excellent, Winnie. Indeed it would. But what really matters is the amount of mass in a given volume of space, which means its density.
Density.
Density, that's the ticket. The denser the object, the greater the curvature of space-time around it.
So if a ray of light were to approach an object that was extremely dense, it would...
be forced to travel along paths of greater and greater curvature, quite right.
And therefore it would be a struggle for light to escape the pull of an object that was extremely dense?
True.
Huh. Oh, but what was it you were saying the other day about, a Snow White?
Not Snow White. I was talking about white dwarfs.
Right.
Aging stars, swiftly running out of gas to burn. Perhaps a little like me.
Oh, I wouldn't worry about that, Arthur dear. You still have plenty of hot air left in you.
But not nearly as much as I need, funny Winnie. There's still so much left to do. Take, for example, the very exasperating problem of white dwarfs.
Well, what's wrong with the poor things?
Winnie, my theory of the stars, it works like a charm when it comes to young and middle-aged stars. It explains their behavior perfectly. But when it comes to old stars, like white dwarfs, it fails. Unfortunately, my calculations show that such stars will eventually collapse into an infinitely small and infinitely dense point under the sheer gravitational pressure of their own mass.
Oh dear. But why?
As stars get older, they start running out of fuel to burn. And soon there is no thermal or gas pressure pushing outwards to counter the crushing inward pull of gravity caused by the star's own mass. And instead of curling up quietly into an inert ball of matter, as any civilized star should, it collapses upon itself into an infinitely dense point, into nothingness.
Nothing. How dreadful.
It's scandalous. Philosophically, a deeply disturbing thought. For nature abhors a vacuum, even as much as she abhors infinities.
And if your Einstein is right, not even light could escape such an infinitely dense star.
True. Infinitely dense, giving out nothing, and therefore impossible to see. It's a divine embarrassment, indeed blasphemous. But why would God ever create such an unnatural object?
So how are you going to resolve this embarrassment of a paradox which you have created yourself?
Quite simply by concluding that such stars cannot exist. My theory must be imperfect, for it's certain that nature is hiding something from me. Exactly what, I don't know. I need more time to find out. But for now, I must go. The shores of Africa are calling out to me.
And I still hope that Herr Einstein's fancy theories will prove to be wrong.
Oh no, Winnie, they are too exquisite to be wrong. Just you wait. I shall return in triumph.
Don't forget your umbrella, dear, for when your triumphs are raining on you.
Oh, leave the wise our measures to collate. One thing at least is certain, life has weight. One thing is certain, the rest debate. Light rays, when near the sun, do not go straight.
One thing is certain, the rest debate. Light rays, when near the sun, do not go straight.
And Eddington was the first to prove it?
Yes, with the path-breaking experiment that only he could have come up with. A total solar eclipse was predicted for May 29, 1919. It was to be visible from the island of Principe off the coast of West Africa. Eddington arrived there ahead of the eclipse with his cameras, his telescopes, and an umbrella. But on the day of the eclipse, it was raining and the sky was overcast. Eddington was worried that he would not be able to make the observation that he had traveled so far?
I wanted to see the light from the stars that are normally lost during the glare of the daytime sun, but which are visible during the total solar eclipse.
Your drama. So much drama. Couldn't you just have seen them at night like the rest of us?
Yes, you could have. But at night, the earth is turned, and the sun is no longer between us and the same distant stars.
But during an eclipse, it is. The sun is still there. It's just hidden behind the moon. Its great mass pulling at the light, emanating from the stars beyond, and bending it towards itself.
Except now, the eclipsed sun cannot drown out the faint light of the stars with its own brilliance. And so what we should see are rays of starlight being bent by the sun, just like the crooked image of a stadium of the waters.
If indeed it bends. And to know that, we must compare the positions of the distant stars during the eclipse with the positions of the very same stars at night.
If they coincide, Newton was right. But not.
But if they do not, Einstein is.
The matter could be easily resolved by photographing the stars during an eclipse and again at night.
Which is what I was desperately hoping to do on that cloud-infested afternoon in Principe, when all of a sudden, God waved his hand, and like a miracle, the clouds disappeared. And in the eclipse darkness of high noon, the stars shone bright and clear. And I saw through my mind's eye, I saw the same thing through my telescope.
Mass spends space, space spends light.
Eddington returned to London, ready to present his findings to the Royal Astronomical Society.
Friends, astronomers, my countrymen, I've returned from my African safari, and I have with me the photographic images which will determine if Sir Newton is right or Herr Einstein. The photographs of the stars taken during the eclipse at Principe on May 29th. The photographs of the same stars taken at night. Yes, the stars have moved by precisely the same amount predicted by Einstein in his theory of gravitation. Gentlemen, colleagues, Albert Einstein is right.
The world was stunned. Our understanding of the universe had been changed forever. Einstein became an overnight celebrity, a hero. Now, this was the first time that many people had even heard of him.
And Eddington, he became your hero, your guru?
Not just mine. He became everyone's hero. Everyone who cared about science and humanity. Here was a man who had risked personal disgrace and rejected political boundaries to uphold the truth. But for Eddington, Einstein's general theory of relativity may not have been proved for years to come. And that would have been a great setback for science.
So Eddington became Einstein's champion.
No, Einstein was far too great a scientist to need a champion.
But Chandra certainly needed one. He was lost when he arrived here in Cambridge in 1930. If it hadn't been for Arthur, he would never have found his way. I still remember the first time he came to our house. Oh, he looked so young then. Young and shy. Like a schoolboy who had been summoned to the headmaster's office.
Ah, Mr. Chandrasekhar, so here you are finally. I hope you found your Cambridge feet by now.
What an honor, sir. An absolute privilege. Your work has been such an inspiration for me.
Well, I too have been hearing of all the good things that you have been doing. Professor Fowler was most impressed with the paper that you sent in.
Thank you. That was nothing, sir. Just a minor application of the Fermi-Dirac statistics.
They went on talking. None of it made any sense to me, of course. But I did notice that Chandra was shivering from time to time. Understandably, Arthur's intellect can be terribly intimidating, especially to a young boy fresh out of India.
Chandra was not intimidated by Eddington's intellect. He had enough and more of his own. He was simply feeling cold in the horrible, damn English weather. And it wasn't just the weather that was chilling.
Though the poor boy was in a state of nervous tension, He had made a few most peculiar calculations while on the ship from Bombay to Dover, which he believed to be of fundamental importance. He wanted to know what I thought.
I wasn't the least bit nervous. Why would I be? We were talking about my favorite subject, mathematics. But I was terribly excited. Here I was, amongst the greatest physicists of the age, Rutherford, Dirac, Thomson, Eddington, people who were making path-breaking discoveries of their own. And I was sitting across the table from the great Eddington himself, chatting away about my own discovery. Or so I flattered myself it was.
I, of course, knew right away that Chandra's calculations made no sense at all, but he insisted on showing them to me in all their torturous detail. What could I do? I indulged it.
I could see that Eddington was getting more and more curious about my work. He kept questioning me about my assumptions. I was so flattered by his interest in my little paper. Oh, I was happy, so happy in those early days in Cambridge.
He looked tired, hungry. I wondered if I should offer him something to eat. Chandra was a strict vegetarian, but I doubt whether the English knew what vegetarian meant. I had no idea what Indians ate. How could I? There were hardly any of them around in Cambridge those days. The only one I knew of was a mathematician who had worked with our dear friend Professor Hardy, and that was nearly 10 years ago. The poor man had died of consumption, I believe, the result of poor diet. I had seen him a few times. He looked just like Chandra. The large, bright eyes. A strange, awkward young man with a strange, unpronounceable name. Ramanujan. Srinivas Ramanujan, the first Indian to be elected a fellow of Trinity College. Chandra was the second. Anyway, it doesn't matter. But there was a story going around about this Ramanujan, about his stay in Cambridge. Apparently, he once drank Ovaltine without realizing it contained powdered egg. Later, when he discovered what he had consumed, the poor man was so upset he was almost driven to suicide. Oh, that story was going around and around in my mind as I watched Chandra chattering away with Arthur. What could I offer him? Biscuits, cake, toast, but who knew what they contained? I chose the safe option. Would you care to have a slice of the sun, Mr. Chandrasekhar?
I beg your pardon, Miss Eddington?
My sister is fond of jokes. She fancies herself to be a comedian. You may ignore her. As you were saying.
Oh, yes, sir. I must confess that I don't entirely understand it myself, but my calculations seem to indicate that the existing theories of white dwarf stars may be wrong.
During his 3-month-long sea voyage from Bombay to Dover in 1930, Chandra had studied the problem of white dwarfs, originally posed by Eddington.
My model had indicated that aging stars would collapse upon themselves and shrink into nothingness once they had exhausted their supplies of fuel. A conclusion which had disturbed me for many years, until 1926 when my colleague, Professor Fowler, extended my theory and rescued the unfortunate stars from vanishing into oblivion.
Fowler showed that quantum effects, the same forces that prevent an atom from collapsing on itself, would be strong enough in a dying star to counter gravity and thus prevent that star from collapsing on itself. And so the star should spend the rest of its life as a white dwarf and end up as a cold sphere of iron.
With great difficulty, we had managed to restore order to the heavens, when, out of the blue, this young boy from India arrives with his novel arguments and threatens to plunge them all back into chaos. Mr. Chandrasekhar, could you please explain yourself in simple language? I will look into the mathematics later.
Yes, sir. Actually, it is quite simple. I'm surprised no one has noticed it so far. But the fact of the matter is that Professor Fowler has failed to take into account the special relativistic effects that must exist within highly dense stars.
Mr. Chandrasekhar, are you saying that Fowler's prediction of the final state of the stars is wrong because of special relativity?
Not in all cases, sir. Only for those stars whose mass is greater than 1.44 times the mass of our sun. The ones below that limit will cool down and become stable cores of iron, just as Professor Fowler predicted. But for a star above that mass, the quantum forces will not be strong enough to counter gravity. And so that star should continue to shrink and shrink until
what?
Can't say exactly, sir. But if the mathematics is correct, the star should continue to shrink and shrink until it collapses into an infinitesimally small space. Into nothing.
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 I see. So the Lord God, that made such a profoundly logical world, where every blade of grass has a reason for its existence, would simply allow one of his largest, brightest, and most massive of creations, an entire star, to dissipate into nothingness.
Yes, sir. So it would appear.
A remarkable conclusion, Mr. Chandrasekhar. Congratulations. You've taken us right back to square one.
I don't see how I could be wrong.
Well, we'll see about that. But this nothingness, which contains an entire star within it, what do you call it? What happens inside?
Well, sir, it's hard enough to imagine such an object, let alone name it or understand what goes on inside it. But it must be immensely dense. And so the gravitational effects around it would be tremendously strong. Perhaps strong enough to prevent even light from escaping from it. But then we would not be able to see such an object. That's impossible. Or is it? I mean, then it would be like a...
Congratulations, Mr. Chandrasekhar, for discovering what must be the strangest object in the universe. A creature born out of the union of special relativity and quantum mechanics, which then conducts the rest of its life in accordance with the laws of general relativity, and does all of this behind a cloak of invisibility. Quite remarkable.
I think I'm wrong, sir. Perhaps, but I've checked my calculations over and over.
What you are saying is a travesty against God and nature.
Against God and nature, sir, but God lies in the equations.
And yet the equations of men can lie. Oh, you see, my dear boy, natural law requires that a star go on radiating and radiating, and then contracting and contracting until it finds peace in the cold state of inertness. Nothing can find peace in nothingness. I'm afraid, Mr. Chandrasekhar, that if your stars contradict natural law, then my answer is quite simple. Such stars cannot exist.
Such stars cannot exist. Exactly what the church had told Galileo 400 years ago when he discovered the Medicean stars and the moons of Jupiter. Galileo had nearly lost his life. What hope then for my Chandra?
Mr. Chandrasekhar was shocked, and naturally so. But it was Arthur's reaction that surprised me. He was shaken. I could see that.
Mr. Chandrasekhar, would you mind leaving your calculations behind? I'd like to take a closer look at them. Who knows, once we weed out some of the more obvious errors, there might even be a publishable paper here.
As you wish, Professor Eddington.
Come, young man. There's no need to look so disappointed. It is a brave attempt, although a misguided one. You're still young. Your work shows great promise. In fact, I have a proposition for you.
Yes, sir?
How would you like to come and work with me? I am quite sure I can find a use for your considerable talents. Well?
Of course, sir. Be my privilege.
Very good. It's settled then. I'll see you in college next week.
He bullies you. He savages your work. Yet the moment he asks you to work with him, you promptly agree. Why?
What could I do? How could I contradict him? A 19-year-old against the greatest astrophysicist of the age? What else could I have done? Besides, what if he's right? That would mean that my equations are wrong. But they're so beautiful, so elegant. How can they be wrong?
And what was all that mumbo-jumbo about God and natural law? He just swept aside all your hard work with one grand statement. Natural law requires that a star must go on radiating and contracting and contracting and radiating until at last it finds its peace. Well, it appears to me that natural law is equal to Eddington telling nature what she should do.
Lalita, what you must understand is that Eddington was a devout Christian, a Quaker. His belief in God was so strong that he became a conscientious objector during the war. He was shunned by his neighbors, by his colleagues, but he steadfastly refused to join military service because it went against his religious beliefs. Now, a man like that could genuinely believe that the idea of a black hole is blasphemous, a heathen notion.
You crazy scientists. You do everything in your power to eliminate God from your equations, but when they don't work to prove you're right, you bring God right back in.
These scratches and squiggles of black ink on white paper. Does any of this matter? Who cares if a star disappears into nothingness or becomes a ball of iron? As long as our good sun rises in the morning and sets in the evening, why should anyone care what happens to the rest of the stars? Let them all vanish into darkness, I say. I wouldn't lose any sleep on it.
But I care. I must find out. I must know. It's like a monstrous itch that must be scratched. It's an overwhelming need to discover the truth. It's like a fire that burns inside of me that must be fed. These are not just scratches and squiggles of black ink. This is mathematics. It is the most powerful and only instrument that we have to know the mind of God.
And Chandra's mathematics reveals a God who isn't to your liking?
Careful, Winifred.
You're hiding something from me, Arthur. What is it? Is it the glory of God that troubles you? Or your own?
What do you mean?
You know what I mean. Oh, this is about those dreary E numbers again, isn't it? Oh, Arthur, those numbers will be the death of you. You're obsessed with them.
Leave me alone! What if I am wrong?
Professor Eddington, sorry I didn't see you there. Please have a seat.
Busy as a little brown wolf, prying into the secrets of the sky, Chandra?
Nothing much, sir, just trying out a few things.
Well, Chandra, I have been studying your paper on white dwarfs with renewed interest.
Oh,
Most interesting. I think there are possibilities, distinct possibilities, which must be explored at their logical ends.
but I thought you said it went against natural law that such things couldn't exist.
Oh, Chandra, who am I to decide what can exist and what cannot? That power lies only with God. Who knows? Perhaps your mathematics may provide us with a way to understand it better.
Oh, I don't know what to say, sir. That is extremely generous of you. I'm not sure I deserve all that high praise.
Not at all. Not at all. A brilliant young man like you is just what we need to shake things up a little bit here in Cambridge. A new star, shall we say. But now let us get down to business, Chandra. I have an important matter I'd like to discuss with you.
Yes, sir?
There is a tide in the affairs of men, which when taken at the flood leads on to fortune. Omitted, all the voyage of their life is bound in shadows and in miseries. Do you agree, young man?
Of course, sir. How can I disagree with Shakespeare?
Your moment is coming, Chandra. I believe it is time that your work is presented to a wider audience.
Think so, sir?
Yes, Chandra. I am increasingly of the opinion that your work is of fundamental importance. Heartbreaking. Quite. But that is only my opinion, and individual opinions do not matter in science, do they? Otherwise, we would be back to the bad old days of the Inquisition. I believe that it is time that you present your findings to the leading authorities in science and see what they have to say.
Actually, sir, I have been talking about it in various colloquiums. Both Mill and Fowler have seen my work.
Now, shut up. Tweedledee and Tweedledum. They will take you nowhere. You, Chandra, are an artist of rare merit. You need a much wider canvas. Now, Now listen to me. The Royal Astronomical Society is holding its annual meeting in London on the 11th of January. You must present your paper there to the best minds in physics, astronomy, and mathematics. How does that sound?
I don't know what to say, sir. A lecture at the Royal Astronomical Society. By me. It's beyond my wildest imagination.
But richly deserved. I think your work is of such crucial importance that I have asked the Secretary to permit you to speak for a full 30 minutes instead of the usual 15.
I don't know how to thank you, Professor Errington.
It's all for science, Chandra. Your moment is coming. I think everyone who is anyone will be at this meeting on the 11th of January. I personally invited several important people. We should have a full house. But good, now that's settled. Let's get down to some work. Let me see your latest calculations.
Yes, of course.
Ah. So, you still haven't considered the case of the interacting electrons like I advised you to do last week?
No, sir, I haven't.
And why not?
Because, sir, it makes no difference to the end result. You see, Pauli's exclusion principle applies to the electrons, and so the interactions between them become irrelevant.
I see.
But, sir, the real problem is with these differential equations here. They're proving very difficult to solve.
Oh, yes. Oh, yes, nasty. Very nasty indeed. Would you mind if I took a copy of these papers to mull over, apply my feeble-minded problem?
Of course, sir.
Thank you. Oh, Mr. Chandrasekhar, a most intriguing thought has just occurred to me.
Yes, sir?
You're quite right. These calculations are indeed very long and tedious. So why not unleash our latest technological marvel, the calculating machine, upon this forest of equations?
Calculating machine. That would indeed be a godsend. But I believe it's not given out to anyone.
Oh, come, Chandra. You're not anyone. You're someone. Just leave it to me. I'll take care of it. The calculating machine is as good as yours.
I don't know how to thank you, Professor Errington.
All for science, Chandra. All for science. And the important thing is that you must be completely prepared before the big meeting. There's not much time left, is there?
Dear Babuji, I am overwhelmed with the work I need to do before January on my stellar structure. As the meeting day approaches, I feel I'm in a pretty deep mess. Yours respectfully, Chandra. Chandra wrote this letter to his father a few days before the big meeting at the Royal Astronomical Society on January 11th. It was a freezing cold afternoon in London. Chandra arrived at the meeting hall a half hour early. It was already packed from wall to wall. Rows upon rows of men sat in their starched white shirts and black jackets, squashed against each other like sardines in a can. Eddington was right. Everyone who was anyone was there. Fowler, Hardy, Jeans, Milne, Stratton. But Eddington himself was nowhere to be seen. Minutes before the meeting was to start, Eddington swept into the hall, the audience making way.
The room had no windows, no ventilation. The air was thick with the breath of so many people, hot and humid as a tropical swamp.
The room was pleasantly warm, just like in Madras. It felt really nice after the chill outside. The meeting began as soon as Eddington had settled down. One by one, the speakers got up to deliver their lectures. Someone spoke on the possibility of air existing on planet Venus. Eddington, of course, had his own opinion.
Never mind Venus. There's no air in here. It's like the bloody black hole of Calcutta. Now, can we please get started on Mr. Chandrasekhar's talk before all of us suffocate to death?
This was Chandra's moment. The moment he had dreamt of for 5 long years, ever since that magical sea voyage from Bombay to Dover in 1930. The air was thick with expectations.
President Stratton, gentlemen, in conclusion then, for a star of small mass, the white dwarf stage is an initial step towards final extinction. But for a star of large mass, we are left speculating on other possibilities.
Thank you, Mr. Chandrasekhar, for that quite interesting talk. Are you done?
Yes, sir.
In which case, with your permission, President Stratton and the august audience present here, I should like to say a few words. I do not know if I shall leave this meeting alive, but the paper that you have just heard, the foundations of it are completely wrong.
But Professor Ellington?
No buts, Mr. Chandrasekhar, no more buts. I've discussed this with you earlier as well, and you refused to see reason. Gentlemen, colleagues, members of the Royal Astronomical Society, it is my painful duty to inform you that Mr. Chandrasekhar has put the stars back in precisely the same difficulty from which Professor Fowler had earlier rescued them. Mr. Chandrasekhar has placed us in the very difficult situation from which only an accident may intervene to save the helpless stars. And I, for one, need more protection than that.
How can you say that, Professor Ellington? You've seen everything that I presented here today. You've personally checked all my calculations.
You've had your say, Mr. Chandrasekhar, for 30 minutes, no less. Now kindly allow me to have mine. Yes, I have seen your latest calculations, and it is precisely because I have seen them that I am driven to the conclusion that they are reductio ad absurdum.
My equations are absurd, but you yourself said that they
I said that your combinations are based on combination of relativistic mechanics and non-relativistic quantum theory. And I do not regard the offspring of such a union as born of lawful wedlock.
What about Dirac? He did the same thing.
Yes, he did, but it has nothing to do with your conclusions. President Stratton, gentlemen, I think there should be a law of nature preventing a star from behaving in such an absurd manner. It's nothing short of stellar buffoonery. Thank you for your time, gentlemen. I have nothing further to say.
They laughed at you? No one spoke up for you.
Not one person. That was that. The meeting ended, and the room emptied out. I stood there looking like a fool. People threw me pitying glances. A few of them came over to pat me on my shoulder. All they could say was, "Too bad, too bad." That evening I returned to Cambridge. I didn't have the heart to face my cold, dark rat hole of a flat. So I went to the common room in Trinity College. There I stood in front of the fireplace, staring into the embers as the lines from Eliot's Hollow Men kept running through my head. This is the way the world ends. This is the way the world ends.
Not with a bang, but with a whimper.
That winter's night in January, my world had come to an end.
You trusted him? He trusted you.
Yes, I did.
Yes, he did. He had no reason not to.
You didn't stop to think for a minute why he'd become so friendly towards you? His abrupt U-turn didn't make you suspicious?
No, I just thought that he had finally understood the significance of my work.
E numbers again. There's nothing in your life apart from those E numbers of yours. No rest, no food, no sleep.
Very soon my theory will be able to explain all natural phenomena. Every known and unknown equation that governs the physical world will be derivable from my theory as a special limiting case. I'm building a church for him.
Oh, your ambition, it frightens me, Arthur.
Look at this, a cornerstone laid down by Einstein. And over here, a spire raised by Newton. And here, the altar built by Heisenberg, and all of it illuminated by the divine light streaming through Maxwell's stained glass windows.
See, sounds loony to me.
It's my life's mission, my personal crusade. Call it what you want to. But I must do it, I must. I can't stop now, but I'm so close to the truth. Listen to me, Winnie. My E-numbers are going to be the key that will unlock the secrets to the universe. Very soon, I will be able to integrate special relativity, general relativity, and quantum mechanics into a single, grand, unified theory.
Did you know what Eddington was up to?
I believe he was trying to combine all known physical laws into a single all-encompassing theory that he called fundamental theory. It was all very hush-hush. Eddington was very secretive about it. All we knew was that he had come up with something that he called E-numbers.
E for Eddington, I suppose? How very modest.
The theory of everything. I almost have it. Soon, every mote of dust in the universe will owe its existence to me and my mathematics, my pure, clear mathematics.
Very few people took his E-numbers seriously.
And yet the greats of Cambridge continued to treat him like he was God.
Yes, most people were still in awe of all the path-breaking work he had done in the past. I was still in awe of him.
Arthur, what if you are wrong about Chandra's work? He's only a boy. He looks up to you. He admires you so much I can see it in his eyes. Are you sure you are doing the right thing?
He is wrong, and I know it. It had to be stopped.
Good evening. Germany has invaded Poland. Fighting has begun in Europe. That's the headline tonight, Friday the 1st of September, 1939. Warsaw has been bombed. Casualties are heavy, but Poland is fighting back. Mr. Chamberlain has sent an ultimatum to Hitler. Pull out of Poland or we will declare war. Hitler has told the Reichstag he's fighting for the resurrection of Germany. Here, all three services have been ordered to mobilize and are ready. The evacuation of the main cities has been going to plan and the blackout has begun.
September 1st, 1939, physical review.
On continued gravitational contraction by Oppenheimer and Snyder.
Gravitational contraction, is this about...
Yes, yes. It's the same old nonsense about the collapse of stars.
Nonsense? Why? Does it contradict your theory?
No, it supports it in every respect. Even extends it to the general relativistic case.
Oh, that's wonderful, Chandra. You've finally been vindicated. Why are you looking like that? This is the best possible thing that ever happened to you.
They haven't even mentioned my name. Not once. Let alone cite my original paper. Apparently they worked it out by themselves.
They didn't mention your name?
No.
Oh well, never mind. How does it matter? An independent confirmation of your arguments only strengthens your case, doesn't it? It should be easy enough to prove that you were the first person to come up with this as early as 1930, a full 9 years before Mr. Oppenheimer and Mr. Snyder.
Perhaps. What purpose will it serve?
What do you mean?
Lalita, I have spent most of my adult life grappling with the problem of white dwarf stars. A problem that matters to no one except me. 9 years. 9 prime years of my life have I wasted chasing shadows. But I have decided now. Enough is enough. That chapter of my life is closed and I do not wish to open it.
But this paper by Oppenheimer surely changes everything.
Changes nothing. What is done is done.
But Oppenheimer is the blue-eyed boy of American science. Surely his confirmation of your findings will count for a great deal. Why are you giving up so easily, Chandra?
Giving up? For 5 long years I didn't give up because I was a fool. If anyone else had been publicly humiliated the way I was in the hands of Eddington, they would have given up much earlier. But I didn't. After that meeting of January 11th, I met the creme de la creme of European physics. Bohr, Pauli, Dirac, Max Born, Rosenfeld. I showed them my work. I offered it to them for their review. I challenged them to find any fault in my arguments if they could.
And what happened?
They said Eddington was wrong. They said he was talking through his highly inflated hand. They said I was right, Lalita, each and every one of them.
They said it in private.
In private, man to man, with a sympathetic arm draped around my shoulder, over the sympathetic clinking of wine glasses and the sympathetic clucking of tongues. Oh yes, in private they were all on my side, but in public, never. In every conference, every seminar that they attended, with their studied silences, they were all with Eddington. Not one man amongst all those great men breathed a word against him.
You never wrote to me about these things.
There was nothing to write about, Lalita. I had very little to show for all my exertions. Eddington was just far too powerful and influential. In the years that followed, he never missed an opportunity to make fun of my work. All my attempts at rebuttal just made matters worse. People started mocking, calling me a Don Quixote tilting at cosmic windmills. Even Bill turned against me. Bill, the only friend I had in Cambridge. Do you know what he said?
What?
Your marshalling of authorities like Board, Pauli, etc., impressive as it is, leaves me cold.
Chandra, you have to let go of the past. We are in America now. It's a new age. It's a new time. Thousands of miles away from your snake pit in Cambridge. And this time, you and me by your side, not Mill. Look at me, Chandra. You can't give up now, not when you're this close to victory. Oppenheimer's paper changes everything. Fate is giving you a second chance, a new hope.
False hope, Lalita. No one will even notice Oppenheimer's paper. Stillborn child, destined to be forgotten by everyone but its parents.
But Oppenheimer's conclusions are based on pure mathematics. If the mathematics is correct, how can anyone object to the conclusions?
Huh. That's what I used to think when I was young. Not anymore. Mathematics is in the hand of God. It's the opinion of men to be accepted or rejected based on convenience. In any case, the world is changing. Mathematics of the stars has no relevance in these times.
But why?
Bombs! Bombs! Blasted bombs! Blast us all out of bloody existence! As if Hitler and his bloody tanks weren't bad enough.
Do calm down, Arthur. Here, have an apple.
Calm down. How can I calm down? Have you seen what's written in there?
September 1st, 1939 physical review? On continued gravitational contraction.
No, not that one. That's just some rubbish that Oppenheimer's written. Europe is under siege. Do you think anyone cares two whits about the stars anymore? No, it's this article after Oppenheimer. Here, this one, by Bohr and Wheeler.
The Mechanism of Nuclear Fission by Niels Bohr and John Wheeler.
The evil genie has been released from its cage, and thither it will never return. Lucifer, son of dawn, has cast off his chains, and the oceans will be turned into barren deserts, and kingdoms will tremble before him. This time, no one will escape. They are going to drag us all into this meaningless war that will destroy God's world, and they will unleash the fires of hell upon his creation.
What are you going on about? Who will?
Every bad jack of them! Bohr, Einstein, Fermi, Teller, the lot. They've all gone off to America to make the bomb. The bloody atomic bomb. And this paper by Bohr and Wheeler is the last piece of the jigsaw puzzle. Maybe it ought to be a matter of months before they make it. There's no time left. There's no time. I must finish it. I must finish my church to him. It will be man's finest homage to God. My papers. Where are they? Here they are. The theory of everything. I almost have it. I'm almost...
Arthur! Oh, this excitement isn't good for your health. The doctors have warned you so many times.
I'm fine. None of us will live much longer anyway if our friends in America have their way. I must finish my paper on the fundamental theory before they do.
I must move on. When the world is on the brink of collapse, The collapse of the stars hardly seems relevant. I have to do something else. I cannot spend my life chasing shadows. But what can I do? What am I capable of? All I know is that my star-crossed journey has come to an end.
Chandra's in America too, isn't he?
The University of Chicago, I believe. Why do you ask?
I was just wondering, what is he up to these days? Ballistics?
It's a military project, okay? The American government has asked me for my help.
And you agreed.
There's a war going on, Lalita. How can I refuse?
The fragmentation of bombs, calculating the optimum height of releasing a bomb to ensure the maximum dispersion of its fragments. Chandra, how can you work on such things?
A little bit of willpower and good old Newtonian mechanics. But I know what you mean. Not exactly box-breaking work.
No, Chandra, that's not what I meant. You're using your knowledge for the wrong purposes. You're solving the wrong problems.
Oh, I agree. There's far more important work going on the Manhattan Project. That's where everyone else is. Oppenheimer, Fermi, Teller, all busy trying to build the bomb. The atomic bomb. The most powerful weapon ever conceived by man. If we can build it, the balance of power will shift and we can end this terrible war much sooner. Why are you looking at me like that?
You never told me about these things.
Well, actually, I'm not supposed to tell you anything at all. It's all very hush-hush, top secret. But now that you know, don't go around telling your friends about it.
Who would I speak to, Chandra? I hardly know anyone in this place apart from you. And even that I'm not so sure of sometimes.
Oh, yes. I'm sure my earlier work would have come in very handy on the Manhattan Project. In fact, I know that Teller has been showing a sudden interest in my work on radiative transfer and stellar dynamics.
Stellar dynamics? Your stars have something to do with atomic bombs?
Of course! What is an atomic bomb but a tiny star made by man? Look at the sky. Every twinkling point of light is a highly efficient machine that's converting tons of matter into energy every second. E equals mc squared. It's the same equation everywhere, whether it's a star or an atomic bomb. Lalita. Technically though, the first few bombs are probably going to be based on the fission mechanism, as outlined by Bohr and Wheeler, and not fusion, which is the primary process within a star. Oh yes, I could have done so much more than ballistics on the Manhattan Project.
Then why don't you go and join your friends there?
Government regulations, only American citizens are allowed on the project.
But Bohr's working on the project. Has he become American?
Bohr is there only temporarily, as an advisor. Besides, Bohr is Bohr, the godfather of us all.
And what about Teller? Isn't he Hungarian?
Yes, he was, but now
And Fermi, he's Italian, correct?
Yes, but
Well, I see. So the American government is willing to accept Great Danes, Hungarians, Italians, Austrians, Alsatians, and even German shepherds for its top secret project. But not Indians.
Lalita, you're going too far.
Chandra, don't you see a pattern here? These great men from America and Europe for whom you work so loyally, have they given you an iota of the respect that you deserve? No one stood up for you and Ennington made a laughingstock of you. They refused to give you a permanent position in Cambridge. And Oppenheimer, he didn't even mention you in his paper. And now they use you to design their horrible bombs, but keep you out of their inner circle. Copenhagen, Chicago, Cambridge, it's all the same. Don't you see, Chandra? You are not one of them.
Nah, this is not about me versus the Western scientists. It's a much larger battle. It's the choice between democracy and fascism.
Big words. They mean very little to me. I can't bear the thought of science being created to use these instruments of death and destruction. This is not what you're meant to do, Chandra.
And what if Hitler builds the bomb and destroys humanity? Huh? If the American government has asked me to contribute to the war effort, how can I say no?
America, America. Your newfound loyalty to America is only to butter up to the establishment here, so some big fellow like Oppenheimer or Teller finally recognizes your work. Admit it, Chandra. You're still carrying that paper on white horse like an albatross around your neck. I'm sorry. I shouldn't have said that. I got carried away.
I have buried my past once and for all. Don't keep digging it out again and again. You understand?
I told you. I'm sorry.
I'm working on the war effort because it's the right thing to do. It's my duty.
Your duty to America. I see. What about your duty and love for your motherland? Chandra, what have these people ever given you but pain and suffering? Things are changing in India faster than you can imagine. Very soon the British Empire will crumble into dust and India will gain its freedom. And when that day comes, people like you will be needed for the task of nation building. What will you do then, Chandra? How will you use your God-gifted talents? To create or to destroy?
It's an unfair question, Lalita. I'm just a scientist. I have no control over how my work is used. That is up to the generals and the politicians, not me. I have no choice.
But you have a choice, just like Eddington did during the Great War. Chandra, why can't we go back and work for the good of India? Why must we spend the rest of our lives in this cold and distant country where we'll always be outsiders?
Yes, I am an outsider, a stranger in a strange land. And not just here, but in my own land as well.
But your own uncle is establishing the Raman Research Institute in Bangalore.
So you want me to join Raman in Bangalore? Unfortunately, he does not share your views. He wrote me a letter a few months ago. Do you know what he said?
What?
I will never allow astrophysicists to step within 100 kilometers of Bangalore.
Your own uncle said that to you?
Why are you so surprised? There was never any love lost between the two of us. Raman thinks that astrophysics is a pseudoscience. So no, he will not welcome me back, nor will anyone else. No, this is where I must stay and do what I can.
But don't you want to go back?
I don't know what I want. There was a time, a long time ago, I wanted to look into the hearts of stars. I wanted to create the new science of black holes. I tried, and I failed. Now, I just want to keep myself busy. Ballistics, hydrodynamics, and ellipsoidal sections. Their intractable mathematics make demands of me that I struggle to meet. The more I struggle, the better I feel. I just want to keep running around an endless track. Faster and faster until I collapse. I don't remember what happened. That's what I want.
Yes. And you want to design weapons for a war that has nothing to do with you. But I don't blame you. This is all that Eddington's fault. He destroyed you, Chandra. Why did he do it?
Don't keep breaking up the past again and again. It serves no purpose.
Human beings do not obey the laws of quantum mechanics.
The answer doesn't change every time you ask the question.
In that case, for the last time, what is the answer?
I've said it 1,000 times before.
He said that my work was fundamentally wrong.
Yet not one person could find a single mistake in your work. It was perfect, flawless.
The mathematics was flawless.
But mathematics isn't everything, as Eddington used to say.
That's rich. Coming from a man who spent 15 years of his life trying to derive every known law of the universe from pure mathematics.
My work cannot be compared with Chandra's. My work was completely rooted in physical reality, whereas Chandra's had nothing to do with the real world. Why, how could one even conceive of an invisible and infinitely dense singularity in space which had no basis for its existence apart from mathematics?
And yet, Heisenberg's uncertainty principle, Einstein's field equations, and Dirac's predictions of antiparticles and negative energy, did any of them have any basis for their existence other than mathematics?
But that's different. Those were all works of white men. Those men automatically qualified for a place at the high table at Trinity College.
Oh, rubbish. As if I cared a fig whether somebody was black or white or any shade in between. Unlike Chandra's, those theories qualified for a place at the high table because
they could be verified by experiment.
But surely not when they were first proposed.
No. But unlike Chandra's invisible infinities, they offered the possibility of experimental verification. It was only a matter of the right time and the right technology. Besides, the sheer beauty of those theories meant that they had to be right.
Truth is beauty. Beauty, truth, as Eddington used to say.
Actually, I was only quoting Keats.
And Eddington didn't find your theory of white dwarfs beautiful?
Beautiful. It was ugly, an abomination. a monstrosity.
No one but a heathen could conceive of such a thing.
Please, Lalita.
If I could tolerate Chandra's bizarre ideas for so long, surely I could tolerate a little brown skin. Such things simply didn't happen in Cambridge. Not cricket, as they say. Why, one only has to look at the Hardy Ramanujan episode for proof.
And Ramanujan, as you know, was as dark as me, perhaps a few shades darker.
Ramanujan. Ramanujan to them was the poster boy of the exotic East, a fakir mathematician who had mystical equations whispered into his ear by a four-armed Hindu goddess, the antithesis of your very English Arya. But you were different. You were just like them, weren't you? As rigorously methodical in your science as any Englishman. They knew that if they let you have your way, you would have beaten them at their own game, the greatest game the West has ever played. Science.
Racism, colonialism, jealousy, an overinflated ego. What exactly am I guilty of? It's my faith, I suppose.
It's none of them.
It's bizarre the way you keep defending this man. The eulogies, the memorial lectures, the glowing references in your Nobel acceptance speech. Even the food packets.
Food packets?
Yes, Chandra, the food packets you sent him from Chicago during the war. You tried to hide them from me, but I saw the address on the parcels. Couldn't believe my eyes.
He was seriously ill, Lalita. He had stomach cancer. It was killing him. The doctors had advised him to eat well for a fighting chance of survival. Meat, vegetables, milk.
But there was a war going on. There was rationing. We didn't have any money. It was all spent on treatment. We could hardly afford 2 full meals a day.
How could I turn my back on him at a time like this?
I did it all for science.
I know.
Yes, for science. But your science. Ellington science.
White man's science.
Arthur, after that disastrous meeting in the Royal Astronomical Society, I kept asking myself, why did you do this to me? But I could never come up with a satisfactory explanation. Until the winter of 1946, when the answer finally became clear to me. That was the year your book was published. The Fundamental Theory. Your magnum opus.
It was 2 years after my death.
The fantastical outpourings of a mind that had lost its way.
The pinnacle of my achievements. The result of 15 years of unrelenting labor. The theory of everything, a comprehensive explanation of why the universe is what it is. I had proved the existence and properties of every single particle in the physical world, from first principles, from pure mathematics. So I thought.
No one remembers it today. It's less than a footnote in history.
No one remembers it. The fools. They don't understand anything. I had shown why the proton must exist and why it must have precisely the mass that it does. Why I had even shown why the number of protons and electrons in the universe must be exactly 136 times 2 to the 256. Not one more and not one less.
A remarkable conclusion. And easily verifiable by experiment, I suppose. This is what Einstein had to say about your work. Eddington's imagination was not adequately balanced by his critical faculties. Pauli was rather more direct, I'm afraid.
Complete nonsense. For romantic poets, not physicists. That's what Pauli said.
That's the way the cookie crumbled. This is what it was all about, wasn't it? The grand fundamental theory, the precious C numbers. This is why you had to destroy me and my work. Because if you hadn't, it would have destroyed you. All this while you were hiding behind the physical impossibilities of infinity and your self-proclaimed love of natural law and of God. But the truth was far more mundane, wasn't it? All you were trying to do was protect your precious C numbers from coming to an embarrassing end. And how do I know all this? Because I remember. I remember that fateful afternoon in Cambridge, when you came to my room with your oh so magnanimous offer for my 30 minutes of fame in front of the Royal Astronomical Society. I remember what you said to me then.
So you still haven't considered the case of the interacting electrons like I advised you to do last week?
No, sir, I haven't. Because you see, Pauli's exclusion principle applies to the electrons, and so the interactions between them become irrelevant. That is the crux of the matter. Your fundamental theory was based on the assumption that every particle in the universe must necessarily interact with every other particle. But my theory of the white dwarf stars made no such assumption, and yet it was correct, completely correct. Given time, it would have been experimentally verified as well. You were in a fixed hour. If you accepted my work to be true, you had to accept that yours was not true.
True. What is truth? Do any of us really know? Truth is not a multiple choice question with one correct answer. It is an indeterminate equation with countless solutions. Did I destroy you, Chandra? And if I did, why did you go on honoring me throughout your life? I don't have the answers. It doesn't matter anymore. After all, we are only human. Small, pitiful, stupid creatures that don't know why we do what we do. And our thoughts and actions can no more be explained by reason any more than we can extract the square root of a sonnet.
The square root of a sonnet.
Well, that's what we poor humans are. The square roots of sonnets. Impossible conundrums. Unsolvable equations.
If only you had solved the right equations, things could have been so different today. You were my guru. Together, we could have done for modern astrophysics what Galileo and Newton did for classical mechanics. We could have done 40 years ago what Hawking, Penrose, and the others are doing only today. Together, we could have made history, given birth to the new science of black holes. But you solved the wrong equations, and I lost 40 years. Science lost 40 years.
No, Chandra. I lost. I lost everything. You won.
Won what? The Nobel Prize? Gave it to me at the age of 73 for a trivial piece of work that I had done when I was 19? Who will give me back all those wasted years? 40 years. I could have done much more. So much more. But it's all right, Arthur. It's not your fault. Because you didn't destroy me. I destroyed myself. Fate, dear Brutus, is not in our stars, but in ourselves. Yes, Arthur, I forgave you. Because in the end, you didn't matter. Only science did. By the age of 73, I had even made a few original contributions to the emerging science of black holes, and that has been enough for me. For the pursuit of science is like the scaling of mountains, high and not so high. But who amongst us can hope to scale the Everest and survey the entire Himalayan range with its dazzling white of snow stretching to infinity? There is nothing wrong, or low, or mean in standing in the valley below, awaiting the sunrise over the Kanchenjunga. They also serve, who only stand and wait.
No, Chandra. You did much more than that. You scaled the highest mountain even as you thought you were standing in the valley. Look, Chandra. Mankind watches the heavens through your eyes. Come now. The sun is rising. And soon the stars will fade into the light, just like you and me, and everyone that we ever knew.
Yet like the invisible stars, our memories will remain, and perhaps perhaps one day our stories will be told.
Our revels are now ended, and these are actors, as I foretold you, are all spirits, and are melted into air, into thin air.
We are such stuff as dreams are made on, and our little life is rounded with a sleep. Thank you, ladies and gentlemen. I'd also like to call on stage our stage manager and producer, the amazing Richard Garg. And the director of the play, Ranjita Chakravarty. Ladies and gentlemen, you were a great audience. This was our second performance over this weekend, and we have two more performances. One is this evening and another one tomorrow. Our next production, we normally perform at Sunnyvale Theatre. Our next production is at Sunnyvale Theatre. It opens on May 28th, and it's called Name, Place, Animal, Thing. It's a beautiful play. Hopefully some of you will come and enjoy it. Thank you very much to City Lights for allowing us to perform here. So we will take a short break. It'll be just 5 minutes or so. And whoever wants to stay back for the talk back, we'll be here to talk through some of the science, history of science, and of course, the play itself. Okay? Thank you very much. Choudhury is the director of the play. We also have a Netflix series regarding the role on Never Have I Ever. So in case she looks a little familiar, it's because of that. And Professor Raja Chakravarty, who you've already heard from, and Ambassador Pradhan, I'm the artistic director there at Rama. So, do you have any questions, or should we just start talking? Okay, I guess everyone understood the science completely. Go ahead, John. Go ahead.
Yes, I'm curious about the representation of Ranjita and Edison's sister, and how much of that came out of records and shared communications versus, the work of the playwright and also your vision as the director.
So, if you, in the play, Lalita doesn't, she just comes across like whatever, the words that she's saying. But I did some research, quite a bit of research when we first mounted it. Lalita was actually a physicist in her own right. So she was not just a housewife looking after home interest. She was actually, went to college with Chandra. And in the later years, she gave up her career to take care of Chandra's, matters. And some of the music that I have put in there is actually a tribute to Lalita. I mean, the playwright had not done this. Lalita was a very accomplished veena player. It's kind of like a big, it looks like a sitar, but it's not. It's like called a veena. And she's also a vocalist. So some of the music and one of the songs she used to sing for Chandra is, the vocal sound, Tiruvati Charanam, which talks about birth and rebirth, and it kind of is a metaphor for Chandra because he reinvented himself every 10 years. So none of this is really written in the play, but I kind of needed to get some context. Winnie, on the other hand, there are no pictures of Winnie. But we do know she was the
older sister of Eddington, and basically took care of him till his death. So she never married, neither of them married actually, but Winnie never married, and basically she was literally packing his gumboots and boiling eggs. I mean, I don't know where that came from, but it is believable that she did that. And so yeah, so it's a little bit from what the playwright said, a little bit from what I could gather. Very little is written about Winnie, so that is a little bit of license that maybe. But I took both when I wanted to, even though the play is about two men, I wanted to give the women like a place of importance. Like Lalita is the one through whose eyes we see everything. Why are you so dismissive of your achievement? She asked upfront, and then through her eyes we actually see what his achievements are, and he realizes. So that, and then Winnie is like, to me, she not only is a caretaker of Eddington, but also his moral conscience, because she's what I call an innocent colonialist. Hurrah for Mr. Newton and the bad German theories. But in the end, she says, are you sure you're doing the right thing, Chandra? I mean, so she's his moral conscience in a way. So yeah, that's how I figured out the two women, and then it's up to the actors how they also choose to play it.
I guess there are detailed interviews with Lalita that you relied on,
Yes.
and there's a very detailed biography of Chandrasekhar by Chakravarty, who passed away a few days ago, I think.
Oh,
Yeah, Chakravarty passed away very recently, but he interviewed a lot of people who knew Chandrasekhar in writing that biography.
Shed some light on how life ends in the space-time environment.
We should ask Chandra this question, actually. But,
Yeah, light, I mean, light is energy, but does it really have mass?
no, so that's a great question. So, normally, this is how I explain light bending. Those of you in the audience, including Chandra, if you want to walk my definition around that, you're welcome to, pun intended. When you think about light traveling, it follows the path that's going to take the least time to get from point A to point B. And the very definition of warped space-time is light takes a shorter amount of time to go along the path from point A to point B than it would going in a straight line. So it always takes the path of shortest time. That's how I explain warped space-time to my students. It is it has no choice but to follow that path.
So, the straight line is the shortest distance.
In flat space-time, it's the shortest distance. In the absence, if all masses are located far away and there's no discernible warping of space-time, that's travel in a straight line. And mind you, these deflections we're talking about, when a light ray grazes the surface of the sun, the deflection is 1.4 degrees. So it's a tiny fraction. By comparison, it's a very tiny deflection. It's not a large. Sorry, it's 1.4 degrees, 1.4 arc seconds. 1.4 arc seconds. And an arc second is 1/60th of 1/60th of a degree. So it's a very tiny fraction. The sun's diameter, by comparison, is half a degree. So this is 1/1800th. Sorry, 1/3600th of a degree.
Why, of course.
Thank you.
Yes.
I just want to say that we both were very impressed with how well you remember all the astrophysical details and how fluently
You're talking to them, I assume, not me.
Not even to him and Brian and
He had to memorize the housekeeping announcement. That was
it was mind-blowing the way you remembered and the fluency with which you communicated with each other, the way you guys interacted. It felt like you guys are astrophysicists who actually know.
This is high praise because it's coming from Varun, who teaches introductory physics at UC Santa Cruz, and Chandra in front of him is an expert, is a physics expert, is a particle physics theorist and expert, all the way from the East Coast. She happens to be visiting California. I'm really I'm proud of all of you, and I especially appreciate you being in the audience.
Yeah, and I'm an astrophysicist too. I work on galaxy structures, so I could totally connect with what you were saying. But I was listening to you, and I was just really very impressed that you didn't miss anything. Like everything, it felt like you not only connected with the material, but it was as if you are astrophysicists talking to each other.
So you are one of those grown men staring at the stars, whiling away your time without doing any work. Okay. Bye.
Thank
So, I have a question.
Thank you. I was just saying Winnie's line.
I've really enjoyed it. Thank you. But this is a science question. I think the first time I heard something which I may have got totally wrong is that gravitational force is not a fundamental force, but it's really a byproduct of space-time distortion. Is that, did I get it right? Could you expand on that further?
So, Einstein does tell you to think of gravity as a distortion of space and time, and not as a force. And it actually goes back a long way to, the basis of general relativity is something called the principle of equivalence. And it goes back to Galileo's experiment of dropping two objects of different mass from the leading tower of Pisa and seeing that objects of the same mass fall at the same rate. Now, this was seemed like a trivial experiment. You drop two things, they fall at the same rate, so what? Big deal. The other forces of nature, the other forces are electromagnetism, weak nuclear force, and strong nuclear force. How the force works, or how things move in response to those forces, depends on the identity of the particles. So, simple example, if you have a positive charge and you bring another positive charge close to it, it will get repelled. But you bring a negative charge, it will get attracted. It's the same electric field, but different objects are responding differently, moving differently, based on their identity. In this case, how much charge they have. That's not true for gravity. Everything moves the same way, independent of their identity, which in this case is mass. So there's been this long-standing struggle to understand why gravity treats everything so democratically, whereas other forces don't. And Einstein's theory is revolutionary. It says that it's not a property of the material at all. It's space and time itself that's getting warped. And once you do that, it's natural why everything should move similarly through that warped space-time. I don't know if that helps.
Kind of.
Yes.
Towards the end, there's a line that says, I think Chandra says it, which is that if we hadn't had this thing back in the speech that he gave us, we would have done what Penrose and Hawking. Can you talk a little bit more about that? Would that counterfactual actually help or not?
No, that's
Penrose, Hawking, Professor Speeds to me.
So, Hawking passed away recently. Penrose was recognized with the Nobel Prize recently. They did indeed do great work together on the science of black holes. This is one of those things. That door was never opened, and that wave function never collapsed around Chandrasekhar and Eddington. What might have been is, it's rightly left for speculation. We don't know what if Eddington had taken a different stance towards Chandra's equations. They certainly did great things in spite of this rift between them. And one can only imagine how great their contributions would have been had they worked together. Maybe Chandra wouldn't have switched fields every 10 years. Chandra wrote a series of books at the end of every 10 years that completely changed the field, and he would just stop, move to something else. He did that 4 times. So, the 40 years that he talked about losing weren't really lost.
What are the fields? What kind of?
So he worked on dynamics of stars in stellar systems. Now stars moving in a field. So this whole thing of something called dynamical friction is an equation that Chandrasekhar wrote down. And this is something that Ivala was talking about on Friday in her talk, and I was thinking about the irony of this. That evening I was going to be talking about Chandrasekhar in this play, and she was demonstrating the effects of dynamical friction in the Andromeda galaxy. That's an example of something. Stellar structure was, of course, the thing that he and Eddington cross swords over. What else did he do? Chanda, Varun, do you remember? What other things? Mathematics of black holes, okay. Okay.
He has a treatise, a big fat book, Mathematical Theory of Fractals.
Radiative transfer was another thing he did.
Statistical theory.
Statistical mechanics. So Chandra is unusual in having PhD students in the subjects of mathematics, physics, and chemistry. He had PhD students in all three subject areas. It's quite remarkable. I don't know too many. Very interesting.
What do we know about what Chandrasekhar was like as an advisor himself?
What was Chandrasekhar like as an advisor?
Yeah, what was Chandrasekhar like as a PhD?
So I met him for one afternoon. His reputation, though, was huge. So Chandrasekhar was very formal in how he presented himself. He was very, very formal. I remember when David Weinberg and I went over to the Institute to pick him up. He was just sitting at his desk, impeccably dressed. He was sitting at his desk, nothing to do. He was just sitting at his desk waiting for us. He was just that, he wouldn't be lounging on a sofa. He was that kind of person. He was a tremendous teacher. He taught a class at the University of Chicago. Rumor was there were only 2 students in that class, graduate students, and he would drive all the way from Williams Bay, Wisconsin. He was director of Yerkes Observatory. He would drive to Chicago to teach this class with just 2 students in it. Apparently he was a really fast and reckless driver. So students they knew he was driving, they would, get this chance to get a ride with him, and there would be a lottery about who was willing to sit next to him, who else would cower in the back seat while he drove. So these are rumors about Chandra's driving. This class that he taught in Chicago became legendary. There were 2 physicists who took that class. They later went on to becoming great physicists, Yang and Lee. They got the Nobel Prize before Chandra got the Nobel Prize. And so they were the 2 students he was driving all this way to teach. I don't know much more than that about him as a mentor. Varun, Chandra, I don't know if you've come across Chandra as a mentor. Any stories or anecdotes of that?
When I was a summer student at Chicago, he was working at very high pay. Private faculty who were younger and had been mentored by him when they were young faculty. But I never heard of the physics community is full of personalities, and people don't always like each other, particularly in departments like that one. But everybody had genuinely positive things to say about him, not just neutral, but positive. And about Ranjita as well.
How about Ranjita?
Eddington demolishing his own students so publicly at the conference looks like a bit strange in a little bit that we can explain that
Really happened.
And actually, some of the language that we used that was there in the play was the actual language, the words, stellar buffoonery and
Reductio ad absurdum.
Reductio ad absurdum.
Born out of wedlock. These are exact words from, those speeches were recorded.
Now, this is not, these phrases were not in just one speech, because Eddington kept deriding Chandrasekhar through the years, as Chandra mentioned. And many of these phrases were across many different speeches, but really was very good.
Yet they were very good friends, because Eddington would take Chandra to Wimbledon. Eddington wrote to Chandra 2 days before he died. So of course, Chandra totally admired Eddington, and Eddington also had this great soft spot for Chandra on many things, but this was the one thing that, I don't know, they were like this. So
They went to concerts together.
They went to concerts, and they both loved Shakespeare. Like he would actually arrange concerts for them to go to. They would quote Shakespeare. That's why there are a few Shakespeare quotations. Eddington was a crossword puzzle solver, and Chandra in some interview he was saying how Eddington used to solve the crossword puzzles, and they used to have a lot of other discussions, but this was one thing, and that's the big question. This Nilanjan Choudhury, the playwright, why did Eddington do it? He claims that this is not like a historical, he's not coming to any conclusion reason why Eddington did what he did, because no one really knows except Eddington. And even Chandra, he was always annoyed by this, but he forgave. Even in his later years when he would talk about this, he actually let it go, he let it pass. So.
Was the reconciliation public?
I'm sorry?
Was the reconciliation public?
They didn't really reconcile like that. He never said sorry for what he did. They actually met in a conference in Paris, I think, or something, and he said that, well, have I hurt you, or I'm sorry if I hurt you, and then Chandra says, well, have you changed your mind? He says, no. Then what are you sorry about? So that's what Chandra said, and this is from Chandra's quotation. What are you sorry about? You know, and something, he said something a little off color, I think, after that, so, which we didn't put in the thing. So, yeah, so it was a weird relationship, Guru Shishya type of, it's kind of weird, yeah, but it makes you think, you know, so, yeah. There's a
What drew you to this play?
I'm sorry?
What drew you to the play?
Well, so this is Nilanjan Choudhury, the playwright. He actually happens to be, we have a lot in common with many years apart. So he went to the same undergrad college, he went to the same postgrad college, he joined the same job I did, same company I did, but many, many years apart. And we also have a very close common friend. So he pinged me and said, hey, you want to take a look at this play? You know, obviously we get a lot of scripts from lots of people. But I liked the play. So I liked the script. We had a reading. It had a lot of challenges to it. And so, but I always thought only Ranjita can do it justice. So I went to her and she did. We did. This is really the premiere in outside of India. So in India it's been performed a few times, but outside of India this is the first time it's being done here. So we did with his permission make changes to the script and then of course we put it in the season. This was the season prior to COVID. Then COVID came, we had to cancel the show. Then we actually staged this as part of our season in 2021 last year in August. So this was the first show we did coming out of COVID, and it was quite fun actually. We had to rehearse in our front yard. We'd given up our space during COVID. We didn't want to because might pay the rent and everything, and we couldn't get a place fast enough. So we just rehearsed at the director's house. Why not? You know. So.
And the original Eddington is here today, Stefan. Only not because Stefan also knows, but we are lucky to have great Eddington amongst us today.
Okay, well, thank you very much for being part of the talk back.
Oh, there's one last one.
Okay, one last question, sure.
In the play, so I think Chandrasekhar said something about his uncle not saying that astrophysicists were not allowed within 100 feet of Bangalore. Could you elaborate a bit more on that?
Well, that's as much as I know. Did you do any research on that?
That's the one thing I did research on. I was so thrilled that he said astrophysics is a pseudoscience. I just left it at that.
Thank you.
I brought in this astrophysics, that's the only one I know.
So this pseudoscientist has actually visited the Raman Research Institute. So I know that band didn't survive forever. Raman's son, one of Raman's sons, Sri Radhakrishnan, was an astrophysicist. So Raman was an astrophysicist. He was a faculty member at Caltech. He left Caltech to go become director of their institute. Rad has passed away. But there is a thriving astrophysics department at the Raman Research Institute in Bangalore. Raman also had an amazing mineral collection. So there's a wonderful gem and mineral museum at the Raman Research Institute, but it's a thriving place for astrophysics today. So that's what I know about it.
I can add a comment. This is just my personal viewpoint. C.V. Raman's era was back in maybe 1920s, 30s. Astrophysics was not a well-developed field as such. Globally, people talked about, say, relativity, they talked about cosmology, but they didn't really talk about it astrophysics. They talked about astronomy, but not astronomy or astrophysics as the same as particle physics or quantum mechanics. These were more exotic things and more like real physics to do. But what is astrophysics? It didn't really exist as a very catchy field as such. I would say much less in India at that time, which is quite ironic because the whole field of astronomy, perhaps originated in India. But at that time, I think the reason why Raman may have said that, I don't know why he said that, is probably because of that. He didn't really appreciate astrophysics as a well-developed field for serious researchers to get attracted to the institute.
I think the fact that astrology is so big in India actually detracts from, if you can't tell the difference, very often I teach my introductory class, at the end of it, students would come up and say, I enjoyed an astrology class at the end. That's me. That could have been part of why he was trying to distance himself from.
But Raman was a scientist. He knew the difference between astrology. I think what he probably didn't appreciate as much is that he didn't want to attract astrophysicists as the scientists we draw to the institute, where he saw more of atomic, molecular, nuclear, quantum physics taking center stage.
I see the birth of a new play.
No.